And this week we're looking at Chapter 18, Fold Thrust Belts. So this is a gorgeous picture to show you the result of what we're talking about. You can see here that we've definitely got folded rock, and this happens to be in an area where we had a thrust fault. So we have folding and thrusting, so it's a fold thrust structure. And when we have a area, we call it a fold thrust belt. So first off, of course, we have to remember what a thrust fault is. A thrust fault is a reverse fault at a low angle, generally somewhere in the 20 degree or less, depending what source you look at. They may say under 30 degrees, they may say under 15, they may say under 10. The very precise definition of what angle it has to be under to be a thrust fault does vary, but the point is that it is a low angle reverse fault. A thrust sheet is the body of the rock that moves due to the thrust fault. It is the rock that is thrust up over the underlying rock. There is more vocabulary on table 18.1, page 446 through 448. It's a lot. I'm going to just cover some stuff, more of the key vocabulary, but all of it's good to be familiar with so that when you're reading, you recognize what things are, or at least you remember, oh yeah, I saw that term, I know where I could look that up. Because although Wikipedia and stuff are quick and easy access places to look things up, they don't always have the exact meaning for geology. So a couple of key terms: foreland direction and hinterland direction. This lets us know where we're talking about. So the foreland direction is toward the undeformed continental interior. So the foreland direction from a mountain range formed by compressive stresses, the foreland direction is on the side of the mountain range toward the continental interior that's been undeformed by the orogenic process. The hinterland direction is toward the deformed metamorphosed zone. So if we're at the foreland basin here in this image, the foreland direction is towards the undeformed continental interior to the left on this image, and the hinterland direction is to the right towards that metamorphosed deformed area. Now the foreland thrust fault, fold thrust belt, is something that we can see down in the Andes in South America, or rather I should say next to the Andes. And this forms when we have a subduction zone, which you can see here in this simplified cross-section, and there is compression going on. So we have mountain arcs forming both due to compression and very much due to volcanic activity. But on the foreland direction side, where we have between basically the foreland basin and the actual mountain range, we have this back arc fold thrust belt. We call it the back arc because it's on the back side of the mountain range away from the subduction zone. And we have this fold thrust activity going on where you can see numerous thrust faults, and you can see the distortion in the drawing suggesting that there's folding going on. On the other side of the mountains, right along the edge of the ocean, we have an accretionary prism. This borders the trench. We're familiar with accretionary prisms from, earlier in this class, in introductory classes and so forth. And within that prism, we can actually get a fold thrust belt. As that prism is built up, bulldozing sediment off of that subducting slab, there is a lot of compressive force. We get thrust faulting, we get other reverse faults, and we get folding. And so we can get a fold thrust belt within that accretionary prism. We can also see fold thrust belts on either side of a mountain range caused by continental-continental collision. This happens when the subducting ocean slab is completely subducted, and so the continent that was on the other side of the ocean is now slamming into the continent on the far side. So this is like what happened when India slammed into Asia, creating the Himalayan mountains. And there is a suture zone in the middle, tiny remnants of that oceanic crust that get trapped and squeezed between the right hand and left hand continental crust in this picture. Obviously in the real world it's east, west, north, south, etc. And on either side we have this fold thrust belt on the upper plate and the fold thrust belt on the lower plate. Even though they're side by side, they're upper and lower based on their relative positions during that subduction. And you can see the angle of the suture zone showing that on the right here was the overriding plate and on the left here was the subducting plate. Again, these fold thrust belts are between the mountains and the foreland basins in both cases here on both sides. The other place that we can get it is an inverted rift. What an inverted rift is when there was a rift basin due to extension, but then millions of years later, the direction of the stress changes, and now we're getting compression. So we have lots of fault planes, lots of areas of weakness from when it was rifting. They were normal faults at that time. Now, because we have compression, those faults can reactivate very easily and become reverse or even thrust faults. And we're going to get folding going on, therefore we're getting a thrust fold scenario, and we actually end up getting hills and or mountains, even though this used to be a rifting zone.